Yeah, so first thing I want to start with is a lot of people are coding this up and finding that their Mario runs through the bricks rather than stops on the bricks like we want it to happen. Out of curiosity, how many people are kind of seeing that? We got a few, not just one or two. So, and however many people raised your hand, I know that 5 times that many people really have it and are refusing to raise their hands because they don't want their friends to know that they're not acing knowledge and everything like that. So let's answer the question, how do we solve that? Suppose that's occurring. Well, first of all, let's make it occur so we can have a problem to solve. Oops. What could cause that? I don't know. Let me go into my model.java and let's make a mistake here. Let's suppose my, let's see, I wasn't going to show you the code for that. Okay, let's suppose my doesCollide method has some bugs here because I didn't check for everything correctly. And I'm going to rebuild. Let's see if this causes the problem. Okay, I have a brick. Hey, that causes a problem, but darn it, it still works. Okay. Darn the robustness of my code. What if I then do, oops. I'm just going to screw some things up here. Maybe this will work. All right. Here's my Mario. You can't go through that way. You can't go through that way. Though it's, darn my code, it's still working. Okay. Ooh, there's a problem. I can't jump. My jumping is now broken. Let's debug that one, and I'll use this as a proxy example for how to debug Mario passing through the bricks. So let's suppose your Mario doesn't pass through the bricks. What do you look at? What do you do? How do you get started on finding this problem? Nobody knows? Well, here's the answer. You can't debug it when Mario's over here. You can only debug it when the problem's occurring, right? Okay, so let's start up our debugger. My debugger is going to be Eclipse. I think that's the debugger we agreed to use in this class. So we wait the very, very long time for it to start up because Eclipse is a big bloated piece of garbage, as all IDEs are. Still waiting. Now's a good time to make yourself a sandwich, if you have a fridge nearby. Wow, okay. Hey, it started. Now, I'm already hooked up to this project. Do you remember how to start your debugger and connect it to your code? Everybody's good? Okay, then I won't go through that again. If you don't remember, go back to the previous lecture and figure it out, because you need to know how to debug your code. This will come up and will be important. Now, I'm going to go set a breakpoint somewhere so I can stop. Actually, the first thing I'm going to do is I'm going to run in the I'm going to make sure I have no breakpoints. I do. I'm going to delete them. Now I have no breakpoints. Then I'm going to run in the debugger and make sure the problem still occurs. My problem was, I can't get on top of that brick. My problem was when I'm on top of a brick, I can't jump. And your problem might be that you pass through the bricks, right? So how can I stop exactly when this problem occurs? Well, I'm guessing the problem occurs with my jumping when I hit the space bar, because it's not jumping, right? So I'm going to come in here and open my controller. And I don't see my controller. So I'm going to stop this thing. Where is my controller? Oh, I go to Project Explorer. and look for controller. There it is. Okay, in here, key space, bam, right there. I'm going to hit my breakpoint right here inside of detecting that I press the space key because that's when my jumping problem occurs, right? Okay, now correspondingly, let's suppose your problem is you can't be stopped by the bricks. You, whoops, I hit jump and it stopped. Do you see that? But that's not when I wanted to stop. And my space key is still down, and that's no good. In fact, I've stopped at the wrong time. Okay, how can I stop when I hit the space key and I'm on top of a brick? Anybody know? Well, I only want to stop when I hit the space key and I'm on top of a brick because that's when the problem occurs. And if I'm stopped right here, do you see how I'm debugging not the problem? And you can't solve not the problem, you have to solve the problem. So you got to stop at just the right time, and that's the hard part. So in order to make this possible, I need to know if I'm on the brick, right? So I'm going to come up here and add a Boolean value. Boolean on brick. Wait a minute, I'm going to pull this. Having trouble seeing, and now I know why. Because it's way over there. Okay. Boolean on brick. Now in my constructor, I'll set on brick is equal to false, right? And when should on brick be true? It should be true when I'm standing on the brick. So I'm going to go to my get out function, and when it tells me that I'm standing on a brick, and I'm going to set that to be true. Where is that? That's right here. On brick equals true. There, I didn't show you my code. But inside of this method, where I got out of my brick when I was, in the case where I was coming down from the top and it was pushing me back up vertically, that means I'm on top of a brick, right? So in that case, I set on brick is equal to true. Now, in my controller, I can say if model.mario.onBrick is true, then system.out.println break here. Then I'm going to put a breakpoint here. Now I'm going to run in the debugger after I kill my program somehow. How do I kill my program? Why is it stopping me? Errors. Oh. There's a problem with my code. Any idea what my problem is? I don't know either, so I'm going back to my shell. Where I'm comfortable, I build cannot find symbol on brick. That's because I didn't capitalize the letter B. Okay. Okay, this is getting silly. Dun, dun, dun. I've now fixed it. Coming back over here. I should just show you, but then everybody will just copy it, and I don't want to do that. Okay. I build it. I run. Now. Okay, I can successfully build. I have one breakpoint in the right place. I'm going to hit my debugger. Okay, follow Mario. Now, notice I can jump, and I haven't hit my breakpoint right yet, right? But I can jump on here. What happens if I jump now? Bam! It hits my breakpoint. See that happened? Okay. That was a lot of setup. That setup, though, is the key to finding your bug. A lot of students will not want to go through the effort to really get to where their bug is. They just want to know where the bug is. How do you do that? You come to office hours and say, Dr. Gatchel, here's what's happening, where's my bug? And then I say, your bug's right there. But that's not the way it's supposed to work, right? It's supposed to be you should know how to dig in and find your bug. And that was a big pain to get to there. But once you're to this point, the problem's as good as solved, right? Let's solve it now. Let's step over. I'm going to be done with this thing. Wait a minute. I've broken here, but this isn't actually where I want to be. After all that work. If I keep stepping out, model updates where I want to be when I'm on top of the brick. So now I'm going to step in again. And now, if I look at my variables, I can see that Mario has a vertical velocity of 0. Ooh, do you see that? His vertical velocity is 0. Well, there's the problem. If my vertical velocity is 0, he's not going to jump, is he? So I hit stop. I'm going to do this again because it turns out we've already hit the problem. Here Mario goes. This is where I want to be. Okay. So the problem is he's not getting a negative vertical velocity, which means he's not going into this if statement, right? Let's confirm that. Yep, he's not going into that if statement. Okay, now I know the problem. I'm going to run it again. Make my brick, jump, hit space. What? I was in the wrong spot. I forgot to hit stop. Okay. One more time. I go into the debugger. I wait till he falls. Jump. Now I hit space. I'm stopped in the right place. I can do step over. And now I want to ask, why isn't this triggering? Because this .model.Mario.frame since I last stood on solid ground is 46. And now you understand why I'm not jumping. Okay? That's not the same as why he passes through a brick, is it? So let's answer the question now, why is Mario passing through a brick? Well, I can't solve that because my Mario won't pass through a brick, and I can't figure out how to make that happen. But let's suppose that was happening. When does Mario pass through a brick? Is it right when you're standing on top? Then he falls through? Let's say that's the case. Where should you put your breakpoint? I'm thinking,
like after that part, after the brick?
Yeah, suppose you're standing on top of the brick and your Mario keeps falling down through it. How would you debug that? Well, I have this code right here called does collide. Where do I call that from? Inside my update method, I call does collide. And if it goes into this if statement, that means, hey, Mario's already hitting that brick, right? So what if I put a breakpoint right here, and I hit stop, and then I debug. Now, Mario will stop the moment I land on top of that brick. You see that? Okay, well this is the point I want to be at because this is when Mario is falling through, right? So now I'm going to call into my get out method, and I'm just going to hit step in. See what happens there. And here I am in the first line of my get out method, which you can't see because the code's really way over here. And I'm going to step through, and while I do, I'm going to watch my variables, and I'm going to see here are the values of Mario's x and y and width and height, and note his prev-x and prev-height. The number one reason, I shouldn't say this, I should make you find it. The number one reason why people's collision detection isn't working is their previous x and previous y are not really where he previously was, and that's causing your logic to not do what it says to do. So check that. As you step through this code, you'll see what those numbers are and why it's going into if statements it shouldn't go into, or not go into if statements it should go into. And if you step through and you see why the numbers do what they do, then you will know what's wrong with your code. Does that make sense? Okay, when you know exactly which line of code has the problem, is it still a problem? No, because then you make it right. And As long as you understand what your code is saying, then knowing what the numbers are will solve any problem. So now you know how to debug it. Cool? Are there any problems that people have that they don't know how to debug that maybe I should talk about really fast? I see no hands. That means you can solve any problem. We're all good. Yeah. Throw it at me.
Step like over and step in. This is confusing.
Okay. What is step over and what is step in? Good question. Right now I'm going to do step out. Oh, step return. Step return means keep on running until you're done with that function and you return to the caller. Okay? Here I'm on this if does collide method. What if I do step in?
Go to the next step.
It will go into the does collide method. If I do step over, it will go down to this print line method. So it's just where do you want it to go to. Now, to be clear, no matter what I do, it's going to do the same set of instructions. It's just when do you want it to stop again? Does that make sense? Do you want me to do one tiny little instruction, which means go into the does collide method, or do you want me to do the whole does collide method and follow all the instructions till it's done, and when it returns to here to do the next method, then break? So step over and step in are the same thing as you can set a breakpoint either here or here, and then you could run until you hit it. And it's a convenience function to save me from having to set a breakpoint and then run and then remove the breakpoint. But you could get along with just breakpoints and the continue button if you really wanted to. Step over and step in are just where it puts the breakpoint. Okay, I'm going to close my debugger. And now I have a fun new topic for you. Whoops, I don't know what I clicked. Okay. Today I want to talk about polymorphism. I like polymorphism. Why? Because it's powerful, and power makes me happy. I'm kind of a megalomaniac. I'm also a pyromaniac, and basically anything that involves power I love. That's why I'm a programmer and a pyro and a chemist and a scientist, because power. What's that? An electrician? I've rewired my home, if that counts. I certainly am not a certified electrician. Yeah, and I could be in big trouble for rewiring my home. So, okay. I built a treehouse recently and I wired it to my house, which was fun. Okay, sorry. Why am I bragging? Polymorphism. Let me open a text editor. Let's first do it at the understanding level, and then we'll drill down into the coding level. Okay, so I'm going to make a class called shape. Now, by the way, have I done this? I feel like I've done this recently. Have I done this in this class? And then I make another class called square, which extends shape. I haven't done that? All right. That many witnesses I must not have, but I remember doing it recently for someone. Okay, maybe I've just taught this class too many times. Well, there. Square extends shape, does it not? Class triangle extends shape. What does all this code mean? Well, this is an is-a relationship. Is a square a shape? Yes. Is a shape a square? Maybe. Is a triangle a shape? Yes. Is a shape a triangle? Maybe. Is a square a triangle? No. Is a triangle a square? No. And yet, a triangle is a shape and a square is a shape. Therefore, a triangle is a square, right? No. Okay, you get the relationship thing. Do you understand extends? Do you understand extends?
Like, can you what it mean? What does extend mean?
What does what mean?
Extend.
Extend. Extends, let me do it pictographically. I'm certain I drew this picture before. Just check me if I'm going insane or not. Tell me if I've done this. Let's call this a shape, and I'll make another one. And I'm going to call this red thing and I haven't said exactly this, that's a square, and this green thing is a triangle. No, you're like, no, you're going crazy, Dr. Ashler. Okay, fine. Well, I might be. Okay, well, let's call this, I think I mixed up the two now. Let's say this one is a square, and this one is a triangle. And let's go back here and say string name int vertices, and squares must have pants because it's SpongeBob SquarePants, and triangles have what? Hats? Floating point named hat. I don't know why. And squares, in addition to having pants, have some number of eyes and color, which of course is yellow. Okay, except I did it green. Well, in keeping with the SpongeBob theme, now it's yellow. Wait, except yellow and white's hard to look at. We'll go brownish. Okay, too many nuances. Here's my point. How many member variables does a square have? 5. Let's count them. 1, 2, 3, 4, 5. Because square extends shape. Do you understand extends now? It adds unto. It extends. I don't know. I can't really describe it any better than that. I'm just going to say it really loud. Square extends shape. And that means it builds on top of it. Okay. Triangle extends shape. How many member variables does triangle have? 3. A hat, a name, and a vertices. Well, interestingly, do you see how a triangle is a shape? Because there's a part of a square that's a shape, and there's a part of a triangle that is... Okay, well, in memory, you see, in memory, squares are bigger than triangles because squares have more member variables. So every square occupies a lot of memory, but the shape portion of the square occupies the same amount of memory as the shape portion of the triangle. So you could, if you wanted to, have an array list of type shape. How can I draw this? What does an array list do? It makes a bunch of boxes in memory which hold variables, and those variables point to a thing of a certain type. And you could very well have those variables reference squares. If this were an array list of shape, meaning array list shape, and we'll call it shapes. Here I have a member variable that can reference this array list. And this array list holds a bunch of shapes. Can you put a square in this array list? Yeah. Yes, because square is a shape. Can you put a triangle in this array list? Yes, because a triangle is also a shape. Can you just allocate a shape and put it in that array list? Haha, trick question. You can't allocate a shape because shape is an abstract class. Oh wait, no it's not. Okay. We haven't talked about abstract yet. In fact, yes, you can. You can just make a shape. And a shape will not have pants or eyes or a color, nor will it have a hat. If you just make a shape, it will only have a name and a vertices. What kind of shape is it? It's not. It's just a shape. So it's just one of these sizes. Oops, it's too small. It should be exactly that size. So if you allocate a shape, then it's one of those. Do you see how it kind of doesn't make sense to just make a shape? Because then someone might ask, well, what shape is it? And it would say, it's just a shape. Well, what shape is it? It's not. What? You know, it's kind of, okay. Conceptually, it feels to me like shapes shouldn't be allowed to exist, whereas squares should be able to exist. And squares are shapes, so in that sense, shape exists as squares, and shapes exist as triangles, but you can't have just a shape. Do you see how that's kind of abstract and weird? There's a word for that in Java. The word is abstract. When you make something abstract, that means you can't make one of them. They exist only for the purpose of being extended. And shapes are abstract in that you can't instantiate a shape. You cannot allocate a shape. So if you try to do this, the compiler will yell at you and say, shapes is abstract, you can't make a shape. But you can make a square and you can make a triangle, which are both shapes.
Is it like static or like cone?
Abstract has a different role than static and const, but it's like that in the sense that you use a word to cause it to happen. So abstract means cannot be instantiated. Has no materialized form. It only exists as a concept. Now, that's kind of funny because do shapes really exist? Well, yeah, but in this program, it's just a concept, right? It's just occupying memory. It's not, your computer doesn't cause a square to appear in the real world. It's just numbers that represent a shape. So in reality, they're all abstract, but this is even more abstract because you not only can't think about it, you can't think about thinking about it. That's not what I meant. What I mean is you can think about a square. You're not allowed to instantiate a shape. You can only, let me be more specific. If you say new square, the compiler will say okay. If you say new shape, the compiler will say something. Want to find out what it says? Let's find out what it says because I don't know. Public static void main string args. Sorry, what was the question?
Is it like, should you work because square is part of the shape, but like shape implies part of something?
So a square extends shape. A shape is more part of a square than the square is part of the shape. So square extends shape, therefore the member variables in shape are part of the square. Does that make sense?
Kind of.
Okay. Well, I'm going to save this code as main.java.
Do the member variables of shape, are they abstract because they're in an abstract class, or do they need to be declared as abstract?
They are not abstract, but because they're in an abstract class, you can't instantiate this class. If you instantiate a square, there really is a name and a vertices in the square object.
So is there any need to make things in an abstract class abstract for the end?
Not member variables. There will be a need to make methods in the abstract class abstract, and I'll talk about that next. Okay, so now javac main.java, and it's going to say error, cannot find symbol color. Yeah, I know. Go away that problem. Error, shape is abstract, cannot be instantiated. Wow, that was a surprisingly clear message. Remember what I said? What does abstract mean? Cannot be instantiated? Well, the compiler agrees. Okay. However, if I stop trying to make a shape, then this code is going to compile, and it worked. Now, what does this code do? It occupies some amount of memory. And how much memory does it occupy? Enough to hold pants and eyes and a name and a vertices. And those four things will occupy one object in memory which is of type shape. And then it returns a pointer to that object which I don't store in any variable. And so the garbage collector will immediately pick it up, and then the program is done. So very worthless program. Want to see it run? Yes, it did it. Okay. So there you go. We made a square. Okay. Now, why did we make a square? Why did we even do that? Well, here's the whole reason we did that. You might want to do things to a shape. What's something you can do to a shape? Draw it. I'm going to make an abstract method in my shape class. Abstract void draw. Okay. In fact, while we're at it, let's make an abstract string getName method, which, no, let's make it not abstract. Return name. Okay. My shape class has two methods. This first one is named draw, and notice I ended with a semicolon and not with a brace. Usually we do braces, but if you have braces, then it's not abstract. So abstract in the case of a method means this method has no body. What's the point of an abstract method? Think of this as a contract. An abstract method says, any class that inherits from me shall have a method named draw. And it better provide a body too. So if I want to make a square, in fact, I'm going to save this and build it right now and watch it. We'll make an error. And now the error is, square is not abstract and does not override the abstract method draw in shape. Do you know what it's telling me? It's saying, hey, wait a minute. No child of mine is going to lack a draw method because I have this abstract void draw thing and I'm not providing the body, so my children do. I don't know how else to say it. So if I come down here to square and I say void draw, and the draw method just does, okay, I drawed it.
I have a question.
Then now that will work, yes.
At the top when we said like abstract void below, is it like function prototype?
This is like a function prototype. That's a good way to describe it. This is me saying there will be a method named draw that has 0 parameters and returns void, which means nothing, in any class that extends this one. Okay, now if I build, I'm going to get an error. Triangle is not abstract and does not override abstract method draw. Okay, so let's take this method. But triangles get to draw a little differently. Triangles draw by saying, yo, I totes did it, which is different. And now it builds, and it does nothing. Okay, well, look at what I can do now. I can say square SQ equals new square, triangle T tri equals new triangle, and I'll say sku.draw, try.draw, and even though they are what's the problem? Cannot find simple triangle. It's right there. Silly compiler. Any dummy could have figured that out. Why can't computers figure these things out by now? I mean, seriously, we are so backward. Okay, says the programmer who hasn't yet solved this problem. Yeah, well, the thing is that's just one of a billion programming problems that occurs, and if we solve that one, people will expect it to solve the next one, and pretty soon they're going to want the compiler to do it all. Somebody should, though. As soon as you write a compiler that just does what you say, what you mean and not what you say, that's going to change the world. People will be able to sit back and just say, I want a game that looks like this, and Mario gets to jump, and the programmer will just crank it out, and you'll look at it and say, that's not it. I want Mario to not pass through the tubes, and all of a sudden it'll work. Do that. Hey Alexa, build me a game. There you go. Yeah.
Some MIT grads actually got that with, you say the rough idea of what you want to do.
Sweet. The future is now. Okay. Yeah. So
How do we like
you watch out, programmers. Your jobs are in jeopardy. Make sure you learn a lot, because half of what you learn is going to be obsolete really quickly. Quickly. I got to use proper grammar as a professor. Okay. Java main. Really quick. Quick is an adjective. Quickly is an adverb. You can only modify actions with an adverb, not with an adjective. Okay. Okay, that worked. Nobody's impressed though, because guess what? This would have happened even if we didn't extend shape and didn't provide those things, right? Still works. So what's the point? Okay, well, here's something we could do. I'm going to say static void draw thyself, which takes as a parameter a shape, S, and says s.draw. And now I can down here say draw thyself square and draw thyself triangle. You see what I'm doing there? Think about that for a minute while I build and run. It still works. Okay. Imagine stepping through this code. Square, SQ is a new square, triangle is a new triangle. You get that we've allocated some objects in memory, right? When I hit this line, draw thyself, suppose I step in. I'm passing to it a square, but this method, draw thyself, is expecting a shape. Is that okay? Yes, because a square is a shape. And it has no trouble with it because there's a shape right inside of that square, right? Remember this picture? Okay, so when it comes here to call this s.draw method, can it call draw? Yes, except there is no draw method in shape. It's just a empty shell of a method. What actually happens when you call s.draw? Well, this one, the square.draw method, overrides the shape.draw method, which basically means when you call s.draw, it takes the actual object and it figures out what the type really is under the hood and calls the one for that particular type of object. So at this moment, is S a square or a triangle? Well, if I had stepped in from here, it's a square, and if I step in from here, it's a triangle. So S is not a square, or it could be either one. And the thing is you don't have to know. You could write a method that only knows how to operate on shapes, and then some guy comes along later and writes a new kind of shape, like a heptagon. 7 sides, by the way, in case you're saying, what's a heptagon? Is that right? Okay. Suddenly I'm questioning myself. I gotta know if a heptagon has 7 sides. What is a heptagon? In geometry, a 7-sided polygon. I got it. Okay. What about a dodecahedron? It's a 20-sided shape, right? Dodecahedron is 12 flat faces. Oh, those are faces. Okay. Oh, that's right. Gon means 2D. Hedron means surfaces. Gon means edges, I guess. Okay, moving on. Are you starting to feel like you get the concept of abstract? Here's the thing. Let's suppose you get it. What does that have to do with the video game? Well, you've written code for a Mario and you've written code for a brick, and your code is starting to look hairy and messy already, right? Now imagine a game that has Marios in it, and bricks in it, and Goombas, and turtles, and clouds that throw spiky guys at you, and the spiky guys crawl around, and there's bricks you can hit, and coins that pop out, and there's also a Luigi, and a princess to save, and turtles to jump on, and when you do, they turn into a shell, and the turtles bounce around. Can you see that this code is starting to just get, oh my gosh, complex? Okay. Inheritance and polymorphism is going to solve this. Yes, question? What does Luigi do? In this class assignment or in the Super Mario Bros. Video game? There won't be one in this class. We're not going to do Luigi. The answer to the question I thought you meant is, so I came into the scene with Mario Brothers, which is a game where it doesn't scroll. It's not a side scroller. It's an arcade style game. And you hit turtles and crabs from underneath, and then they flip over and you jump out and you kick them. Have you seen that version of it? Okay, if you go down to the Penny Arcade, what's it called? Arcadia? Great little place. You can play Mario Brothers. I took my wife there. I got the high score on the game. She was super impressed. It was awesome. Long ago, I used to be a cool gamer. Now I'm a lame teacher. Now I'm a cool, thank you. I appreciate that. Okay, but yeah, then I play the new Mario with my kids, and I push on the plus and he doesn't go, and my kids are like, Dad, you gotta shake the paddle. And I'm like, why should I shake? I hate shaking the paddle. And I'm not connecting with the modern ones. Can't teach an old dog new tricks. Where am I? Oh, and then Mario Kart is the worst. Mario Kart used to be the coolest game. Used to steer the thing. Now you gotta tilt your paddles, and I tilt my paddle all the way over, and I want it to turn so badly I do a full 360, and the thing gets confused and goes the wrong way. And my kid's like, don't be so dramatic, Dad, just turn it a little bit. And yeah, it's just, I don't know, not working. Okay, well, here's why this is going to be a lot simpler, is no longer are you going to write all of your objects and maintain them all. Let me put it this way. Let's look at the instructions. That will clarify a lot, I think. Let's see. Paradigms, schedule, assignment, is it 3? Wait, 3 is the one that's due today. 4, polymorphism. You're going to make a class named Sprite. What is a sprite? Sprite is an abstract concept. It's a picture that moves. How many moving pictures are there in your game? Well, there's Mario and turtles and bricks and everything. They're all sprites. Well, all of those classes are going to inherit from Sprite, which basically means Sprite is just the concept for pictures that moves. Okay? In your model, you're no longer going to have an array list of bricks. You're going to have an array list of sprites. And you're going to have Mario extend sprite. So you'll have class sprite. You'll have class brick extends sprite. And you'll have a class Mario extends sprite. And all of your sprite methods are going to have the ability to update themselves. Or all of your sprites are going to have, all of your sprite objects will have the ability to update themselves. And somewhere down here in your model, where you have an array list of brick called bricks, you're going to get rid of that. And don't just comment it out, just get rid of it. We're really not going to have it anymore. And you're going to make an array list of sprite called sprites. Okay. Now in your model.update method, right now, you're basically calling Mario.update. But here's what your update method is going to look like by the time this assignment is done. It's going to be for int I equals 0, I is less than sprites.size I plus plus. Sprite s equals sprites.get I s.update. And this is going to be your whole model update method. Now think about the implications of this for a minute. This sprites list doesn't just have bricks in it anymore. It's going to have bricks in it. It's going to have Marios in it. It's going to have coins in it. It's going to have, coin blocks in it, and Goombas and whatever else you want to add to it. And yet the model doesn't even know what a Mario is, and the model doesn't know what a brick is, and the model doesn't know any of that stuff. it's just going to run through all of its sprites and to each one say, sprite, update thyself. And Mario's update method is going to do something totally different than the bricks update method. In fact, what's the brick update method going to look like? Pretty much like this, because bricks don't really have to do anything, do they? But what's the Mario update method going to look like? Well, it's going to do this. It's going to do gravity, and it's going to do collisions, and it's going to do all this stuff your Mario needs to do. Respond to your control keys, accelerate, yada yada. Well, the model will have absolutely no specific code in it for your Mario. If it does, you haven't succeeded in the assignment. So let me just rub this in a little bit. If your model update method is more complex than this one, you have not done it right. Okay, so this is it. That's all you're allowed to do in model update, is just tell each sprite to update itself. I guess you can say if it returns something, then delete it. We'll talk more about that in a minute. But really, that's all the model is going to do. The model shouldn't know anything about turtles or Goombas or anything else. And think about why this is powerful. What this means is now you can build sort of a plug-in architecture, right? Imagine a game where the model just is a list of sprites and updates itself. Well, you are one day thinking to yourself, wouldn't it be really awesome if there was this ghost? And it moved towards you, but not when you're looking at it. Only when you look away. I mean, that'd be cool, right? Well, then all you have to do is come along and say, okay, well, hey, class ghost extends sprite, and then void update method, and then in here is if Mario dot looking at me, and you'd write that method, then do nothing else, move toward Mario. Okay, so you write the code for the ghost. Obviously, this is pseudocode and is not going to work. But the beautiful thing is, you're not going to go in your model, you're not going to go mess with Mario, you're not going to mess with anything except for the ghost, and the whole thing is just going to work. And you see how the complexity of your code is not exponentiating, because you've got everything pertaining to the ghost inside of the ghost, and everything pertaining to Mario inside of the Mario. And so now writing this big complex game just means, hey, you hire a team of programmers and they all go write a different character, and then they all throw them into the same game, and it just works because all the model has to do is just update every single one of them. And there's no all the interaction between them is taken care of by the individual objects. Yes?
So do we have to put the collision detection and the get out method inside the sprite, or we just leave them there?
So good question. The one place where collision detection is no longer allowed is the model class. And let me emphasize something. A lot of people complain that you told us to do it this way, and now you're telling us to do it differently. And I understand that, and you're right. We're going to be morphing our code. Code is supposed to be a changing, living entity. Have you ever noticed the difference between a stagnant pond and flowing water? Flowing water is clear and beautiful. Stagnant ponds are green and nasty, and nobody wants to drink from a stagnant pond. Code is like water. If your code is just sitting around, it's bad code. If your code if you keep changing your code, you're constantly hacking on it, it tends to get cleaner and cleaner, assuming you know what you're doing. If it's getting uglier and uglier, there's a problem. You're not the world's greatest coder yet. But yeah, we're going to keep taking this problem and we're going to keep changing it and rechanging it. And try not to be too angry about that. This is me trying to get concepts into your brain. I'm not trying to build code that's never going to be touched again. That's not the point. So yes, we did some stuff in one way. Now we're going to do it in a new way. All right. So Where does polymorphism occur? Right here. The word polymorphism, the word mankind is basically two words, mank and eind. What do these two words mean? It's a mystery. And that's why so is mankind. Yes?
In Sprite Java, are we supposed to have like our Mario class, our Mario class, and our Ray class all in that same file, or do we just need to have like a Sprite class so that we can
Do all these classes need to be in the same file? No. You can put all your classes in separate files. And in fact, it's probably better to put them all in separate files. So I'd make a file named Sprite and a file named Brick and a file named Mario and keep them all separate. Okay. What's going to go in your Sprite class is anything that is common to all sprites. This would be a great place to do collision. And you know how before we passed in an X and a Y and a width and a height? Yeah. Well, now, let's change your code up a little bit, because remember the stagnant code thing. Let's make a static Boolean does collide, and then pass in a sprite A and a sprite B. That was not even code. I don't know why I did that. But do you see how this would be a darn useful function to have? Because you could say, does Mario collide with a brick? Does the turtle collide with a brick? Because the turtle needs to turn around when it collides with a brick. Does the fireball collide with the Goomba? Because then the Goomba needs to go up in flames or then die or whatever happens when a fireball hits a Goomba, or turn upside down and fall off the screen. And if you were to write this method just one time, wouldn't that be really nice to never write that again? I don't want to see a does Mario collide with a brick method and a separate does brick collide with a coin method in your class, in your code. That would just be horrible and awful. The whole point now is we're trying to make everything as modular as possible. What does modularity mean? It means organized into meaningful packages. Well, the whole point of polymorphism is it allows you to write modular code as opposed to the spaghetti code that you have produced so far. And soon it'll be nice and clean. And so this, because this would be a very general thing to do, please rewrite your collide method this way, just because it'll make your life better in the long run. If you don't, at some point you'll be under pressure to write a collision method, and you'll realize you just have this Mario with brick collision method, and you'll get lazy and your code will get uglier, and then you'll make a stagnant ugly pool when you should make flowing clean water. Yes?
What do you do with static instead of this time?
I made this static because you don't need a sprite. Well, there's two sprites here, and I don't know which one is which. You could make, that would be the very same as just doing does collide with. And then, in fact, if I were doing that, I would name it that, because then I'm actually testing does this collide with that. And I would check if this dot x plus width is less than that dot x, then return false. If this dot x is more than that dot x plus that dot width. And do you see how I'm comparing this and that to see if a collision has occurred? Okay. By the way, that's me being funny. This and that is not a, that's not a special thing, but this is. And in my head, it kind of makes sense that by comparing this with that, it's the parameter before and after the does collide with method. Does that make sense? Okay. I've forgotten how many things are on my stack. One of them is polymorphism. The two words are poly and morphism. Poly meaning many, and morphism meaning morph meaning change, and ism meaning religion. The religion of many changes. Here's what polymorphism is. Polymorphism occurs when you call a method and the actual method that is called is abstract or not, or is overridden. So such that the computer doesn't actually call what you say, but has to call something that depends on the object you use to call it. Did that make sense? Let me say that one more time. Whenever you say object.method, and that method has been overridden, then it uses the object to determine which method to call. That is polymorphism. And it's called polymorphism because the behavior morphs. It depends upon the object itself. So if Sprite is a turtle, it's really going to call turtle update. If Sprite is a Mario, it's really calling Mario update. If Sprite is a brick, it's really calling brick update. And so it really calls the update that goes with the object you're using to call it. That is polymorphism. You get what polymorphism is? Cool. Okay. When you make a method that has the same name as a method in the parent class, that's called overriding. Because the new method with the same name kind of overrides the old method with the same name. Oh, by the way, if you have one or more methods in your class that are abstract, the class itself has to be declared abstract or the compiler yells at you. Because you can't instantiate something if it has a method that hasn't been overridden. Yes?
So if it's abstract and then you kind of in the Boolean that you call sprite like.
Okay. If I call sprite.update,
So like in the Boolean underscore line, you call sprite. That wasn't you
Ah.
were creating a new.
if I call update right here, then I can do that, by the way. So I can call update. It obviously can't call this update because this update doesn't even have a body. So which update is it going to call? It's not going to call that's update. It's actually going to call this is update. Because how does it call update? Well, there is no update method. It actually thinks I meant this dot update. The compiler will insert a this dot if it needs to make the thing compile. And so when you say update, that really means this dot update. And so when it calls this update method, it will use the this object and do polymorphism to figure out what to call. Now, if this sprite, is it possible this sprite is not a brick or a Mario, it's just a sprite? No, because it's abstract, and that means you cannot instantiate this class. So this will be a Mario or a brick or something. And whatever it is, it's going to call the corresponding update method. So calling update inside of an abstract class is always polymorphism, because it will always use the this object, whatever object was used to call that method, to figure out which override of the method to call. Did I answer the question? Okay. Do you get how this call right here works? Based on the object itself, it calls the method. As long as you get that, the rest you can kind of figure out. The main assignment in Project 4 is make this class name sprite, make it abstract, inherit from it, put this array list of sprites in your model, and then hack your code until it works again. You're going to get 1,000 compiler errors as soon as you do that. And that's great. It's learning for you. And you're going to have to fix all the errors that it causes, because when you move stuff around, it's going to drag other things with it. And those other things that get dragged with it, you'll have to move things around until you get it all working. And when you do, how do you know if you've done it right? The answer is not really when it works. The answer is when it works and you like your code. If you don't like your code, it's wrong. Here's what I mean by that. If your Mario has things in it that don't feel like part of Mario, you're doing something weird. If your brick has a reference to Mario, that's strange, because bricks don't really need a Mario, right? Okay. But if everything feels modularized and simple and clean, then you're doing it right. Okay? A few other gotchas. If you have lots of member variables, you're doing it wrong. Okay? Use as few member variables as possible. Let me give you an example. While yes, you could say Mario has an X position and a Y position and a width and a height. But you know what? Bricks also have, well, ghosts also have an X and a Y and a width and a height, and bricks have an X and a Y and a width and a height. Do you see how there's a lot of redundancy going on? Well, let's get rid of all of that by putting it in Sprite. And if you do, by the way, don't forget to get rid of this one. A lot of students have X's and Y's in both the inherited class and the child class. What does that do? That creates a nightmarish mess to debug. Because when you say Mario.x, are you talking about Mario's X or the X he inherited from Sprite? Exactly. Don't do that. Okay, so now Mario's, I only have these variables in Sprite because all sprites have those things. And now Mario doesn't really even need to deal with it anymore. See how that's cool? Anything that, so any method that operates on all sprites should be in the sprite class. Any method that only can be done to a Mario should be in the Mario class. So if you have something general like fall off the screen, maybe you want that to happen to bricks and turtles and coins. And so maybe you should put a method up here called fall off the screen that does that, right? Maybe all classes should have a vertical velocity, all sprites have a vertical velocity, except if there's some that don't, like bricks that just sit there, maybe they shouldn't. So if they don't have it, you better put it in the problem specific class. If they do, if everything has it, put it in the general class. Make sense?
What if only
Okay.
one doesn't have indirect?
Well, you can actually make really complex inheritance hierarchies. So you can have sprites, and then you can have gravity subject sprites, or sprites that are subject to gravity. And then you could have Mario and coins inherit from sprites that are subject to gravity, which inherits from sprites. And then you could have bricks that are not subject to gravity, only inherit from sprites. So you can build big, massive, complex hierarchies of stuff. And in fact, that's the way Java is designed to be written. Let's look at an example. Let's look at the Java JPanel class. Here's the class API documentation for the JPanel class. Turns out that JPanel inherits from JComponent, which inherits from container, which inherits from component, which inherits from object. What's that all about? Well, it turns out that everything in the Java class library is part of a great big tree of inheritance. And the reason for all of that is Java is designed to be written using object-oriented programming. And think about it this way. What is a panel? You don't know. A panel is, if you make a window like this, there's this thing called a frame. And the frame has this title bar and this minimize and maximize and close button and this border that you can stretch. Panel is this big area inside where you put your content. Okay? So a JPanel is the important part of your screen. If you look in your code, you'll see that your view inherits from JPanel. That's because your view is occupying the whole part of a window. Does that make sense? Yes?
Is this more Visual Basic programming?
Visual Basic, no. Visual Basic also probably uses inheritance now, at least more recent versions of it. It didn't used to. But yeah. So what's a component? It's basically any graphical thing that Java has written. And if you look in the component method, what can you do to a component? Well, all of this stuff. You can ask if it contains a point. You can ask if you can make a tooltip, whatever that is. You can fire vetoable change. I have no idea what that is. You can get the border. You can get the bounds. Do you see how these are things you could do to not just a panel, but to all kinds of different objects? Okay. Well, it turns out that component extends container. What's a container? I don't even know, something, which extends component, which must be a thing, and that extends object. What do you suppose object is? Object is kind of the Adam and Eve of classes. Meaning, if you make a class named Sprite, what does Sprite extend? Object. If you forget to say extends object, the compiler comes in and sticks that in for you. Everything extends object. Unless you extend something else, like Sprite. In which case, you extend Sprite, but Sprite extends object. Therefore, it's impossible to make a class that does not extend object. Does object have anything in it? Turns out it does. There's a little bit of overhead with making an object because objects have the ability to be cloned and to test for equality and notify and be converted to a string and wait. I don't know what that's about. Yeah, I do. That's synchronization, but we're not there yet. So long story short is there's some overhead that comes with all objects in Java because you inherit from the object class. Okay. As you learn to be a better programmer, you're going to learn that keeping your code organized is the name of the game. In fact, the more organized you are, the more you can build projects of arbitrary complexity. And the less organized you are, the more you're done, right? Because as soon as you don't understand your bug, you can't make any progress at all. And messy code will always have bugs. Clean code will always have bugs too, but you'll find them and fix them easily because it's clean code. So that's why clean code can continue to be built upon and messy code cannot. So learn to keep your code clean, that's important. Please minimize the number of member variables you have. I keep seeing code all the time that has all kinds of things that don't belong, right? You shouldn't have a separate Mario object in your model and in your view and inside of your Mario class itself, right? If you do, that's messed up. You should only have one Mario object. If Mario has an X and a Y position that differs from one in your model that remembers where Mario is, you see how that's getting redundant? So try to avoid cases of redundancy. Try to keep your code as simple and as clean as possible. All right. Let's come back and look at your assignment one more time and see if I've covered all the things you need. Schedule assignment 4. Clean up your code, ponder the elegance of what you've done. I was obviously feeling pleased with myself when I wrote those instructions. Okay, then we're going to add some coin blocks to the game, which apparently pop out bitcoins because I Googled for coin and that one popped up and it was easy, so there you go. So we'll add coin blocks to the game and Mario will hit his head on one and the coin will pop out and it'll pop off to the side. So basically if you sit there hitting your head on the bricks, the coins will start popping off in different directions and something to do. There you go. How hard is this going to be to code up? Well, it'll be a lot easier to code up after you have organized your code into this nice modularized thing where everything is a sprite, right? Because then all of this step involves is write a new class that extends sprite and behaves the way a coin block should behave. And you'll just have an if statement that when Mario hits it, it makes a coin pop out. You'll just make a new coin and add it to the list of sprites, and it'll just fly through the air like gravity does. If you tried to do step 6 before you do the polymorphism thing, you could do it, but your code's going to get nasty complexity. So the real test of this assignment is when you reach step 6, if you think to yourself, wow, that'll take me about 2 minutes, then you've done it right, you get polymorphism. If this step 6 sounds like a burden to you, then you're probably not on top of polymorphism yet, and you really need to go back and spend more time pondering the elegance of how much you have improved your code. I know that sounds totally cheesy, but there's value in that. Good programmers spend a lot of time sitting around admiring their code. I know that sounds vain and Well, it is. But that's okay, because, you know, when you spend a lot of time just thinking, wow, I'm good, it does something to you. It makes you want to write good code all the time, and it helps you keep it clean. And this assignment's all about cleanliness. So make your code clean and then submit it. And then you're ready for the next one. Any questions? All right. Thanks for coming. Have a great day.